Hello, my name is Gaëtan, and today I will tell you about UV, which is a tool to manage Python dependencies and to orchestrate a Python project. So I will give a short tutorial about UV, explain what it does and how to use it for a simple use case. And I will focus on the use case of a researcher doing work with CUDA libraries, so PyTorch and libraries like this. On this first episode, I will give an overview of the basics of UV, how we use it on a very simple project, and I will show a short demonstration. In the second episode, I will show how to adapt an existing project, a bit more complex, and start using UV on this project. And finally, maybe on a final episode, I will talk about the intricacies of using UV on NixOS, which is definitely for a more niche audience. So let's dive right in on UV for a simple project. So what is UV? UV is basically a tool that kind of would replace something like, in a way, pip or Conda or Poetry or even Docker containers. It can be used as a substitute for these, although it does not work the same way and it does not have the same scope. I think it's a very useful, easy to use and powerful solution for managing a Python project, especially for the case of work that we do, for instance, coding deep learning experiments in Python. So basically, I will start by showing how to install UV. So one of the advantages of UV is that it's very portable and simple to install. So I will start by going to this website, docs.astral.sh/UV, or you can also go to the GitHub repository of UV. And in both cases, you will be able to find the bash line to install UV. So it's as simple as that, and it's available on Linux, macOS, or Windows. So I will show here on Windows, but it should work the same way on Mac. So I will copy this command line, and I will just press enter. It will download UV, and it will directly install it to this directory. In this case, so we can see that it's installed. It may require you to restart your shell. So in this case, just close your terminal and open a new one. Once UV is installed, you will be able to run it, and so run, for instance, UV -- version. And if we type which UV, it will show where it's installed. Great. Also, you don't need to be root to install UV. So even if you're on a computer, let's say a work computer where you don't have access to the root account, you don't need it to install UV. So the command line that we just run is available for any user on the system. It will do a local user install. So now that we have UV installed, we will create a project. So for that, we will use the UV init command and write the name of the project. I will use DeepNet for this experimental project. Also, what you can provide is the -p or --python flag and give a specific version of Python. So let's say you are sure that you want explicitly Python 3.11, you can put -p 3.11. Okay. In this case, we won't override this, so I will just use UV init deepnet. Okay, the little loading time that you have seen here is the time it took UV to download Python. So a very good advantage of UV is that it's not using the system's Python. So it's very pure in this way. It's not making any assumption on the system requirements. So as long as you have a macOS or Linux computer, it will download the proper Python version and manage it itself. This is why it was downloading Python. Okay, now it has created our project. I will put in full screen. And so I will cd into it. And you can see that it created a bunch of files in this project. So first, it created a Git repository. As it's a very good practice for any project, but it created a Git repo. We can see also that it initialized the git ignore with very common patterns to ignore for Git. Okay. Another thing that you can see here is .venv. .venv is the location here where UV will create its virtual environment. Under the hood, UV manages all the dependencies through a classical Python virtual environment. So it's not any container. It's not a container. It's not using Docker or whatever. It's using classical venv. So that's a good thing in this aspect. It created also a file, main.py, which is just a hello world, just for us to test our thing. You could ultimately you will remove this main.py for putting your own, of course, your own code and creating any folder like a normal Python project. Another important file is this .python version, which just pins which which Python version needs to be used for this project. So as we didn't specify any version when we created the project, it's using the default, which is 3.13 now. Great. The final file that is very important is pyproject.toml. So this is not something specific to UV. This is basically a standard. This is a standard for Python, so it's common across many different tools. So in this regard, UV is obeying the convention. And you can see that there are a few important information about our project. So the name, the version, you can put a description for the project, etc., etc. This, especially with the dependencies list here, will replace any requirements.txt or setup.py or setup.cfg, these kind of files. It will basically handle all the metadata for our project. Great. And finally, UV will also create another file, but we will see that when we will create a virtual environment. For now, we don't have any virtual environment. You see, the .venv does not exist yet, and so we will see how we will create it. So, speaking of this, how do we run the code using UV? You can do it in several manners, but I will start by using UV run main.py. So this will run main.py with the proper Python version and the proper dependencies for this project. So I will do UV main.py. It says that it's using the CPython 3.13.7 that it downloaded previously. And because it's the first time we run the project, it created the virtual environment. Now we can see that there is this .venv folder that contains our dependencies, our Python, a link to our Python executable, etc., etc. And so when we did UV run main.py, UV, so it created the venv for the first time, and then it activated it locally, and it ran the code. And so we have hello from DeepNet. We didn't need to do anything more. It did everything at once using the UV run main.py command. Alternatively, you can also enable the virtual environment like you would do in a normal one. It's completely possible. For instance, if you want to directly run the code using Python, some command or whatever. So I will use for that source.venv bin activate. And as I'm using the fish shell, I'm using activate.fish. If you're on bash, you just write this. Now you can see here in my prompt, it says that I'm in the DeepNet environment, and if I do which Python is the Python from my virtual environment in DeepNet. And so right now I can do Python main.py. Now I can also deactivate the environment, so I will do that right now. And so right now we are not anymore in the venv DeepNet. Okay, we can still again do UV run main.py, and it runs in the venv transparently. Great. Before going further, I will git add everything, and I will git commit initialize the project. Perfect. So now we have a clear git tree. Now we will see how to add dependencies, because this is one of the benefits of UV is to manage our dependencies. So I will open back our main.py. And I will completely erase it, and instead I will import numpy as np, and I will do print, let's do an f string, random number, and then np.random.1. Okay, perfect. So this is a simple script using numpy. Now, if I try to run this code, UV run main.py, it will not work because the numpy dependency is nowhere to be found. Now, how do we add a dependency with numpy? It's as simple as doing UV add numpy, and that's it. Here, several things happened. First, we can check that our pyproject.toml was changed and that numpy was added in the list of dependencies. So it's properly declared in the list of dependencies that our project needs to run. So numpy is required. Also, you can see that UV added automatically this version constraint, because the rationale is that, okay, you are adding numpy right now, it's very likely that your project will not work with the numpy from 2 years ago. So numpy must at least be 2.3.3, which is the current version. Of course, you could get rid of that, or you could also add a more precise bound. So for instance, we could add numpy equals 2.3.3 if you want exactly this version or any other version constraint. So if I do here, it changed PyProject.toml automatically for this version. So I will re-add NumPy, and I will I will remove NumPy, which you can do using UV. So now it's not anymore in this list, and if I add NumPy again, it's back with the greater than 2.3.3 version bound. Great. Another thing that it did is that it installed NumPy in the virtual environment. So now if I do UV run main.py, NumPy is available in the virtual environment, and we can see that our script worked just fine. And finally, UV also created a file called uv.log. So if I open uv.log, it's not meant to be read by humans, or it's not meant to be edited by humans. UV manages this file automatically, and you just need to know that this is where UV stores all the very precise information, namely hashes and exact version of each currently installed dependencies. This allows for someone or yourself later to rerun this project with the exact same version of each dependency. So it really grants you a lot of reproducibility guarantees regarding dependencies. We can see that the file actually existed before, and it was only saying, okay, we need Python 3.13, the project is called deepnet, blah, blah, blah. But now it added all of this part, which is related to our dependencies, namely NumPy for now. And it says right now the version is 2.3.3. We downloaded it from PyPy, and we have the hashes for all possible versions and all possible platforms. Okay. So this file is very important, but you don't need to bother looking at it or editing it. Of course, it's managed automatically by UV. Great. So now that we have added our first dependency, I will commit everything. So I will add everything, and I will git commit, and we'll say add NumPy code. Good. So I'll quickly show you other commands that you might use, that you might need when using UV. We've seen UV add dependencies. You can also remove a dependency. So let's say we add, for instance, PyYAML, great, and then we can also, so it changes our UV log, it changes our PyProject.toml, but we can then remove it, and once it removes it, you see that we fall back in the exact same state where we were before. Also, if you make, let's say I do some change manually in the PyProject.toml, so this might, so let's say here I add PyYAML again, and here if I enable the virtual environment, I run Python, and I try to import, I think it's YAML or PyYAML. Anyway, it won't work because we don't have PyYAML. I will now run UV sync. So UV sync makes sure that your virtual environment and PyProject and UV log are actually representing your PyProject.toml. So again, UV sync, it makes sure that everything is synchronized between your environment and your project files. Great, I will remove PyYAML again. And I think that's the most important command. You can UV venv will create the virtual environment if it doesn't exist. But again, when you do UV run, it will create it from scratch. So just for you to know, here it says that it already exists. So it asks me, do you want to override it or not? And so I will do no. But again, that's another command that you can use. Okay, that's it for these little additional comments. So now we have done that, and I will now go slightly further in our little toy project, and we will add Torch as the dependency, and we will try to run some actual useful code. So I will now head to get the PyTorch quick start tutorial. I think this is the right thing. Tutorial. Yes, it's this one, and I will directly grab the source code on GitHub. So this is a very simple example training a small network. I will copy the content of the file. I will replace my entire main.py with this file, and I will now try to do UV run main.py. As you can see, it doesn't work because Torch is not installed, so I will do the same as before. I will simply add UV add Torch. So this will download every dependencies of Torch and Torch itself and place them in the virtual environment. So I will speed up while this finishes. Okay, so the download and installations are now complete, and we can see that we have all of these new dependencies in our virtual environment. If I look at the PyProject.toml, you can see that now there is Torch listed here, and if I look at my uv.log, it's much bigger because there are all these new dependencies declared in there. Great, I will start again the main.py, the script, and it still fails because now we also need torch vision. So I will let exactly this, UV add torch vision. It downloaded 2 additional dependencies, and now if I finally try to do UV run main.py, it should be able to work. Okay, so it downloaded the dataset, and it starts now training the network. You can see that it's properly detecting and using my GPU using CUDA device. If I go to NVTop, we can see that I have a job here that is my neural network being trained on my NVIDIA GPU. So let's wait while this finishes. Okay, it's done. It saved the PyTorch model, and it made a prediction on the test set. So everything is good. Okay, so I will now commit these changes to my repository. So I will start by trying git status. Okay, so I will edit the git ignore because we don't want the data set and we don't want to commit any model file either. So I will add that to the git ignore, git status again. Okay, this seems good. So git add everything and git commit start using torch. Great. I have already created a repo on GitHub, so I will git remote add origin with the link to my repo. And I will push force push to erase everything that was there before, and I will push that to my remote repository. Great. And I will now show you how to run the code on another machine, because this is often what is annoying. You get everything working on your local system, and when it's the time to deploy it to your GPU cluster or another workstation, you are annoyed with dependencies issues in your virtual environment or stuff. So now I will show you how easy that is with UV. So I will SSH a workstation that I have that uses another operating system, and so it's a completely different computer that has never seen this project. Okay, let me cd somewhere where I have some free space. I will check that UV is installed by doing uv version. We can see that UV is there. If it's not there, just install it using the process I showed you at the beginning of the video. So I will now clone the repository that I just pushed my project to. So I will grab the URL and do git clone the URL. Great. I will cd into the folder, and we can check that I have all my files over there. And now to run my code, the only thing that I have to do is run uv run main.py. And this will both create the environment and fetch all the dependencies. And very importantly, so I will run it right now, it will start by downloading Python, and it will then download all the dependencies. And again, the very important thing is that thanks to the UV lock, I am sure to have the exact same version of each dependency that I had on my other system where I initiated the project from. And so even if I run this in like 2 years, I'm sure I will have the exact same PyTorch, and I won't have a newer one with a different API that might break some things in my code. So with this, I am very sure to have all the exact same dependencies. So I will speed up the process while this runs, and in the meantime, I will open another terminal to this computer, and I will just run NVTop so that we can check if our code indeed runs on the GPU. So let me speed up while UV downloads all the dependencies. So UV just finished to install all the dependencies, and now the code should start very soon, our actual script. So it downloaded the data, and it starts running this on the computer, and we can see that I have a compute job on the GPU. Of course, it's not a heavy usage of the GPU, but it's actually training right now on the GPU. So I will wait for it to finish, but you can see that basically our code is just ready, and so this could be any GPU cluster, and it runs directly out of the box. So again, as you can see, using UV is very simple. We can just init our project either from a new directory, as I've showed in this video, or using an existing project. You can do UV init in an existing project. And in the next video, I will show you, this was a very toy example. And in the next video, I will show you on a more realistic deep learning project how to bootstrap UV, so how to add all the dependencies, get a clean PyProject.toml, and then try to run the code with the UV virtual environment. That's it for this first video. If you have any questions, please feel free to contact me or to write them in the comment, and see you soon. Bye.